Yeah, so we're going to talk about chapter 15, which is the sleep chapter. Unfortunately, Spencer and I were not involved in the sleep chapter during our time at the class. So this is kind of just going over the PowerPoint slides and just going in depth and talking about them. I'm sure it's going to be very similar to the class lecture. Make sure to show up to class. Don't just rely on me, because I could miss a lot of things that could be really important. But if you can't make it for some reason, I'm here. Or if you're studying. So we start off with sleep. Sleep is really defined by our biological rhythms. And there's 3 different sectors that we focus on. So we have our circadian rhythms. And this is what you hear, it's like a buzzword. You hear it thrown around a lot when we're talking about sleep. It's just like that 24-hour cycle between sleep and wake. He links a YouTube video about it. So if you guys remember from class, it talks about the French caveman, caver. He lived in a cave for a very long time, like 7 months. Yes. And it was really cool because he found out that our circadian rhythms don't really change depending on where we are or whether we have sunlight or we don't have sunlight. Even being in complete darkness for 7 months, it was still on like a 24 or 25-hour cycle. We also have our infradian rhythms. Those last longer. And he talked here about seasonal affective disorder, also known as SAD. These are the kind of rhythms that can go on for months at a time. So these will be much longer rhythm. It isn't going to be like your quick 24-hour. So like for seasonal affective disorder, you'll notice as like the winter months are coming, typically starting in October or November, there's a lot of depressive symptoms that are linked to the changing in the climate or just whatever happens when winter happens. And then we have our, I don't know how to say, ultradian rhythms. And these are our shorter rhythms. So if you think of it kind of like a line graph, you have on one end our ultradian rhythms, which are short. He uses our sleep cycle here, which usually cycles between 90, 110 minutes. Usually 90 though, that's like the average. Then we have our circadian rhythm, which is right in the middle. Not too short, not too long. And then our infradian rhythms, which are very long. Oh, he does talk about infradian rhythms where depression is linked to the amount of light shown during winter. And so in winter months when there's less sunlight, you'll notice more depressive symptoms. Puts a graph up of that. There's actually a really cool light lamp that he uses during the winter months because he's also affected by SAD. And he uses like a big light lamp, and sometimes having that extra light can actually decrease these depressive symptoms. So if you think you have it, check it out. So going into this chapter, since it's the chapter sleep, we're going to be talking about our ultradian rhythms, and specifically the cycle of sleep. Hi Sam, you want to pull up a chair? You'll see there sometimes it'll be 5 stages that will be listed in different ways. So when you go on to the National Library of Medicine, which I use a lot for just like biochem, biotechnology, they have 5 stages, but it's listed as wake, stages N1 through N3, and then REM. But for this class, we're not going to be talking about the wake stage. I think that's kind of self-explanatory. It's when we're awake and our brain patterns are very active. For this class, we're talking about stages 1 through 4 of non-REM, and then we're going to talk about REM sleep. So we're going to start with non-REM 1, stage 1. This is considered our light sleep. And we do not spend a lot of time in this stage. When you look at EEG recordings, we have a very low voltage, so there's not a lot going on. When you look it up, you see a lot of stuff about alpha waves and theta waves, but you really don't need to know that. It's the first stage of sleep, and not a lot really happens. Everything just kind of slows down. We get to stage 2, which is our deeper sleep, and this one is a good one to remember. When you look at EEG recordings, you look at sleep spindles and K complexes. What those are. Sleep spindles, they're really short bursts of brain activity. They occur very quickly. They're only a couple of seconds. Sometimes they can last as short as half a second. There's no reason as to why they do this, but they are thought to block out external stimuli. And then we have K complexes, which are very similar to sleep spindles. Again, those short, sudden peaks of brain activity. And again, thought to block out anything that might wake us up. All right. Stage 3 also sometimes known as stage 3 and stage 4. These stages are our deepest non-REM sleep, and we spend a good amount of time in here. We have our lowest frequency of waves, but we have our highest amplitude. So when you look at these stages compared to like stage 1, where our brain waves are really short, we see really big brain waves, similar to what our K complexes and sleep spindles look like. This is where a lot of stuff, when we get into why the theories as to why we sleep or what the functions of sleep are, what purpose they serve, this is where you'll see a lot of the work being done. So for example, like releasing growth hormones and just like body repair, like tissues, muscles, bones. Memory processing, really big thing. If you remember the hippocampus, which processes and holds a lot of our memories, very active during this stage. So a lot of the good stuff happens. Those would be stages 3 and 4. Finally, our favorite, we get to REM sleep. It's the 4th and final stage of the sleep cycle. You'll typically enter it, again, like 90 minutes after you hit your bed. It doesn't last very long, but it gets longer each time you go through the cycle throughout the night. And it's the deepest stage of sleep. This is where you're going to have your faster breathing, faster heart rate, and faster eye movement, aka the rapid eye movement, what gives it its name. So usually we need more of this when we're younger, so you'll see a lot greater amounts of it when we're in our infancy and early childhood. And as we get older and we get more retired, we don't need it as much. Look at this. It says, it was traditionally thought that REM was the only stage of sleep where we were able to dream. However, research has shown that we can dream at every stage. Our sleep cycle is going to be affected by our biological rhythms. Woo. So like our biological clock is going to depend on location. So not everybody is sleeping and waking at the same time. Like people in France, they're not going to go to sleep at the same time I do. And that's also another thing, timing mechanism, just depending what time of the day it is. And there's also something called Zeitgebers. Zeitgebers? How do you say that? Those are also very basic. They're just kind of any external or any environmental cue that kind of just synchronizes our biological clock. It'll change it depending on where we are or what we're doing. He shows us that also different parts of the brain can affect our biological clock. Some key things to remember: the hypothalamus, that's going to control the onset of sleep. We have the hippocampus, which is going to control our memories, our memory processing that happens or is thought to happen during sleep. Pons, that's really important, and that's going to help initiate our REM sleep. He has a couple others listed on the PowerPoint. Suprachiasmatic nucleus. It's a tiny region of the brain in the hypothalamus, and it's responsible for controlling circadian rhythms. It's right behind our optic chiasm, that's a lot of vision processing that's going to be in our visual cortex. And it's also right above the hypothalamus, again, which helps the onset of sleep. Very important. Remember the pineal gland being our growth hormone. It releases what's important for our sleep section. It's going to release melatonin, which is our sleep hormone. Although pineal gland does release a lot of other hormones. But for right now, we're just going to remember melatonin. If you ever have problems sleeping, you can take actually melatonin to help you sleep. Again, not everybody has the same biological rhythms. So depending on what we call our Zeitgeber, placement, whatever it is, our external environment, whatever's going on. We can either have a delayed sleep-wake cycle or an advanced sleep-wake cycle. So our delayed sleep-wake cycle will be our sleep cycle is delayed, which means we're going to sleep later than somebody else's circadian rhythm. And an advanced sleep-wake cycle, which means we will go to bed earlier. Yes, my trusty neuroscience friend over here, who does not wish to be on camera, is telling me what I've been missing in class. Do what she does. Go to class. Pay attention. But she was talking about how people who are older or people with dementia tend to go to sleep earlier, and then people who are younger tend to go to sleep later. I don't know a single college student that goes to bed at like 8 p.m., but I see a lot of old people who do that. It's really interesting just to go through the EEG recordings. That's just going to look at our brain waves. It's going to be an electrical recording. Those are just really interesting to look at. And not only that, they can help you understand it a little bit better. You can see the difference between the delta and the alpha waves. which are going to change throughout sleep. Specifically in the REM sleep, you'll see a big change in that. Oh, geniculate ganglion. It looks like this is going to be a part, again, of that sensory issue. When you think about that sensory, you get the thalamus. That's also important in sleep. He doesn't mention it in the PowerPoint, but that's going to prevent sensory signals from going into or being received by our cortex. That would be our cerebral cortex, which does a lot of our thinking and processing. Sleep disorders. Sleep disorders. That's a big one. This is something that's, again, very common. You'll hear these pretty often. Insomnia is probably the biggest one. Just the inability to fall asleep, or just patterns of sleep disturbance. They're chronic, they're really onset. You just can't sleep. We also have sleep apnea, when your breathing repeatedly stops and starts during sleep. You'll notice that if you snore really loudly, or even if you get a full night's sleep and you feel really tired, maybe go to your doctor because you might have sleep apnea. And that's going to be non-REM related. That's not going to be occurring during your REM sleep. What is REM related, though, is narcolepsy, which are going to be your sleep attacks. And that's going to be where you're going to constantly, you'll be awake, then you'll fall asleep. Like, I used to follow like a YouTuber who had narcolepsy attacks, and she was really vocal about it. She liked to spread awareness about it, and it was just a really, really cool thing to learn about. This is caused, or it's thought to be caused, by low hypocretin levels. Not sure how to say that. I do know what it is, though. It's a neuropeptide, and that kind of just regulates like arousal or wakefulness. And a neuropeptide, that's just going to be a chemical messenger that's sent out by neurons. So, fancy word for something that just is a messenger and regulates how awake you are. So when you have low levels of something that regulates how awake you are, that's going to cause you to fall asleep more. It also has another name, orexin. So you'll see it on the PowerPoint. He'll say low hypocretin or orexin. How do you say that? Look at that. Hypocretin? Cool. The functions of sleep. Oh, these ones are fun. We don't really know exactly why. There's no like tried or true, this is exactly why we sleep. Which is great, because that means we get to study it more. And that's fun. So one of them focuses on the non-REM sleep phase, and that's believed to just be kind of a repair or restoration. Similar to what I was talking about earlier, you'll see that parts of the brain or just even parts of the body will just be repaired during sleep. So like your bone tissue or just the plasticity of your brain, that's a big one. Sleep helps you repair. There's also the evolutionary theory of sleep. It just suggests that periods of activity or inactivity, like sleeping or waking, it just evolved over time as a means of conserving energy. You'll often notice that people or animals will sleep during times that they're less likely to be attacked. So that's why some animals are nocturnal and other ones are not. We are not. If you think you're nocturnal, you might have a sleep disorder. And then we go into a specific theory that focuses on REM sleep. And that's going to be your memory and your memory processing. A lot of people will study the hippocampus and even the amygdala, which regulates a lot of emotions and sometimes emotional memories. And we'll notice that it's really active, specifically during REM sleep. Sleep will help you process memories, regulate them.
So again, what are the stages of sleep?
So we have wake. He doesn't talk about it in class, but technically not our stage, but it's when we're awake. Very easy. All right, we have N1. This is our light sleep. It's the stage we're not in the stage for very long. We go to stage 2, N2, non-REM 2. When I say N, I mean non-REM. I just don't like to say everything all at once. This is going to be a little bit of a deeper sleep, and we'll spend a little more time here. This is where sleep spindles and K complexes come into play. Those are our short brain spurts of activity. And then we have stage 3 and 4 of non-REM sleep. And this is our deepest stage. This is where our delta waves will have the lowest frequency but the highest amplitude. And if you look at the graphs, you can see what that means. This is also the stage when sleepwalking, night terrors, and bedwetting occurs. Stage 3.
Stage 3 is when that all occurs.
Yeah. But also going into the theory of non-REM sleep when we were talking about repairing and processing. This is where a lot of our body is going to repair itself. So building bone and muscle tissue, strengthening the immune system, focusing on brain plasticity, which is really important stuff. So make sure you get your sleep. And then finally, we have our last stage, which is our REM sleep. This will occur more frequently and longer throughout the night. This is usually the end of like that 90-minute cycle of non-REM sleep. This is our deepest sleep. And it is sometimes associated with dreaming. I think he puts that in the PowerPoint, so if you want something to remember it by. It's also when our heart rate and our breathing and our eye movement is going to quicken. It's going to become rapid. Rapid eye movements.
And real quick, what are the sleep disorders he wants us to know?
He wants you to know insomnia. That's when you can't sleep. It's a chronic issue though, and that's something that's really important because if you have like one night or 2 nights and you're like, oh my gosh, I can't sleep, doesn't mean you have insomnia. This is something that's really onset, occurs frequently, and it'll be a lot of sleep disturbances where you either fall asleep and you keep waking up or you just can't sleep for 2 or 3 periods at a 2 or 3 hours or just long amounts of time. Then we have sleep apnea. That's going to be your disruptancy. Is how you say that? Yes, disruptancy in your breathing during sleeping. So if you notice like you snore a lot or you snore loudly, or if you get a full night's sleep and you wake up tired, go to the doctor. That's going to happen during non-REM. And when you think about REM sleep, you're going to think about narcolepsy. And these are going to be your sudden periods where you fall asleep. And this is going to be due to low hypocretin or orexin levels, which are those neuropeptides that regulate how awake or how aroused we are.
What are the brain parts associated with sleep?
Oh, that's
Down, and I just want to make sure that they're right.
Brain parts associated.
I mean, a lot. There's so many parts of the brain that are associated with sleep, but hypothalamus, that's going to be your onset of sleep. And then the pons is what's going to help REM sleep. Again, really important. And then we have the hippocampus. That's going to be involved with the theory of memory processing during sleep, just being able to remember stuff, having long-term memories, which are important. Sometimes the amygdala is associated with that, but I'm pretty sure he does not want you to know that. We also have the thalamus, which is those sensory signals. He talks about different things that can help make sure those sensory signals are not interrupted. And those would be your sleep spindles and your K complexes, which are thought to help prevent any external stimuli from waking you up. Occipital cortex and geniculate ganglia. More things you see, you hear. Things you don't want to bother you when you are sleeping. Here we go. The suprachiasmatic nucleus. That's going to be involved with our circadian rhythm. And we also have the pineal gland, which is going to release our melatonin. That's just associated with a lot of hormones. So
That's it.
yeah. Good luck. Bye.